Welcome back, and wow, whole number multiplication and division, as if the last lesson wasn't exciting enough with addition and subtraction. Here we are in year 8 level, following the Cambridge Essentials textbook series because that's what I'm teaching to. And wow, we're now going to do multiplication and division. Well, good news, ladies and gentlemen, I am not going to be teaching you your times tables. I am not going to be teaching you 3 times 2. Those of you who do not know that this is 7, 6, then really start to panic because you're probably in junior school. Hello, welcome if you're out there in internet land. Those of you who are cursed with having to be taught by me, that is the exercise that I would like you to do. Exercise 1, B, and those questions there. Again, extension questions, probably not so much for this. Here is a quick recap of some of the work you've been doing before. Now, in year 6, you've probably found that there are lots of different ways we can add, subtract, multiply, and divide numbers. Right? A lot of these are called mental strategies. Mental strategies are really, really important. And sadly, ladies and gentlemen, they are all built on knowing your times tables. If you know your times tables, then actually a lot of maths becomes simpler. Being in junior school, I understand that it can be hard to learn your times tables, but as you get older, your brain develops. Give it another crack. Don't just turn around and go, I'm not going to do this, I can't do this. So here are examples of, for example, multiplying 18 by 16. Can we do this in our head? Absolutely you can. Not by using long division and putting that strange 0 in. 16 is a really, really awesome number because, well, what is 2 times 2? Yep, 4. And what is 4 times 2? 8. And what is 8 times 2? 16. Oh, hold on a moment. 8 times 2 is 16. Wow. So 16 was the same as 2 times 2 times 2 times 2. Just check. 2 times 2 is 4. 8, 16. Well, why is that important to me? Well, if I think about it now, 18 times 16 can be rewritten as 18 times 2 times 2 times 2 times 2. And you're going to say, well, why would I do this? Well, actually, bearing in mind we are trying to do this in our head, there is one number that I'm pretty sure all of us can actually multiply by in our head, and that's the number 2. Because when you multiply by 2, what are you doing? You're actually just doubling it. And the flip side of that is actually when you divide by 2, you are halving it. And as you can see, dividing here actually comes up. So if we think of 16 as 2 times 2 times 2 times 2, then I can now do 18 times 2, which is 36, times that by 2, which is 72, times that by 2, which is 144, and then times that by 2, which gives me 288. Now, I've done all of that in my head. 18 times 2 is 36, times by 2 is 72, times that by 2 is 144, and times that by 2 is 288. Now, even if I didn't have it in my head, what do you notice I've actually used my paper for? Working out. Yes, so the same principle will be used with, for example, if I needed to do 12 times, 32. I know that 32 is the same as 12 times 2 times 2 times 2 times 2 times 2. Just check. 2 times 2 is 4, 8, 16, and 32. So I can now do 12 times 2 is 24, times by 2, 48, times by 2, 96, times by 2, 192, and times by 2 again gives me 19 times 2 is 384. So 12 times 32, just by using mental strategies, timesing by 2, or pencil and paper, actually saves me from being able to use my calculator. What about this dividing business? Well, the same thing works with dividing. So because we have these factors of 2, or these multipliers of 2, if we remember that we go 2, 4, 8, 16, 32, then any of these numbers that we have as a multiplier or as a divider, we can actually do by thinking it in a different way. So 192 divided by 8 can now be rewritten as 192 divided by 2, divided by 2, divided by 2. Now you're going to go, whoa, hold on a moment. I'm happy that worked for timeses, but what about this divide? It actually works for divides as well, believe it or not. Dividing by 8 is the same as dividing by 2, and then dividing by 2 again, and dividing by 2 again. Try it. If you don't believe me, let's do it. 8 divided by 2 is 4. divided by 2 is 2, and divided by 2 is 1. And we know that 8 divided by 8 is 1. Whoa! Mindeth blown. So again, what is 192 divided by 2? 96. Divide that by 2, what do we get? We get 48. And divide that by 2, we get 24. And lo and behold, 192 divided by 8 now is just 24. These mental strategies become really, really important, particularly later on where you have to do some of your exams without a calculator. All right? Now, yeah, calculators are awesome, but you have to try and learn these mental strategies. What about this one? 27 times 9. This can actually be done in 2 different ways. There's probably even more ways of doing it, but the 2 main ones are this. Well, first things first, rounding. We could have worked out 27 times 10. And we know that's 270 because we just bounced the decimal point 1 place to the right. Or, please don't do this, bang a 0 on the end, but don't do that, it's horrible. Well, we didn't want 27 times 10, we actually wanted 27 times 9. So we actually had 27 more than we needed, right? By multiplying by 10, we actually have 27 higher than we needed to. So if I now take away 27 from this, I get 274. Well, that's interesting. Take away, I can't do this in my head. Wow. 3 and 53, 50, 67. No, 243. Wow, this is embarrassing. 243. Yeah. Now, that's one way of doing it, and you're going to turn around now and go, well, hold on a moment, why didn't you edit this bit out? Hey, guys, I'm human. We make mistakes. But what did I notice? I noticed that something wasn't right. How did I notice it wasn't right? Well, when I did 253 and added on 27, I realized I was going to end up with way, way more than 270. This is why pencil and paper is really, really awesome. So that was one way of doing it. Alternatively, as we've said here in example number 2, I could have said, well, why don't I work out 30 times 9? Same idea, but this time I'm rounding up the 27 to the 30. 30 times 9, again, I can do in my head. 9, 18, that's 270. This time, I've got 3 too many 9s. I wanted 27 9s. I've got 30 9s, which means I've got 3 9s too many. So I'm going to take away 3 times 9. 9, 18, 27. I'm going to take away 27, and thankfully, I already know the answer is 243. Whew. Lots of different ways of doing this. Now, generally speaking, we have taught you in junior school how to use algorithms. These are like baking a cake. So I'm really bad at baking. If I actually try to bake a cake, I'd need a recipe in front of me. Now, give me that recipe and I'm fine. I can follow the instructions. I can put 100 grams of flour and I can put 3 eggs and I can put, 200 grams of, what else do you put in cakes? Butter, and I can do that. I can put it in the oven when it tells me to. It's fine. Take away that recipe and I am stuffed. I have no idea. You would not end up with a cake. You'd end up with a right royal mess. So in that situation, I've now become a slave to a recipe. And that's what we do very much in maths. We make you a slave to a specific idea. Fractions is the worst one. We give you 4 rules and people use them all over the place. Let's not even start me off in fractions. But using algorithms, wow, if you remember long multiplication. So first things first, what do we remember we do? Well, for some reason, we always start in this column here and we do the 6 times 5. We go 6 times 5 is 30. Put a 0, and I know my Aussie students are going to go mental, but just bear with it. 3 makes more sense being there. And then we do 5 times 2, because for some reason we do that. 5 times 2 is 10. Add on this 3 gives me 13. Get rid of the 3. In the UK, we were told to rub it out so we didn't get confused. That makes perfect sense to me. And then what do? Well, now we start in this column. We have to put this random 0 in here for some reason. Right? No one really understands. Most of us forget to put it in. And then we start in this column and we do 3 times 6, which is 18, and carry the 1. And 3 times 2, which is 6, and add the 1 is 7. And then for some random reason, because we're following a recipe, we add these together. 0 and 8, 9, 10, 11, 7, 8, 9. So I now know that 26 times 35 is actually 910. Whoa, hard. There are other ways of doing this. We can actually use a grid method. And we can put a times here, and we can actually say 26 is the same as 20 and 6. And we can say that 35 is the same as 30 and 5. Now, the great thing about this is actually we've broken this down and made our multiplication much, much simpler. Because in this box here, in this number 1 box, I just do 20 times 30, which I can do in my head as 600. In box number 2, I've got a 6 times a 30, which again, I can do in my head as 180. In box number 3, I do 5 times 20, which is 100, again, do in my head. And this box must be 5 times 6, which is 30. Now, having got all of those individual ones, I just add them all together. I can even see the plus sign here, right? It makes a plus sign. So 600 plus 100 plus 180 plus 30 gives me 0, 8, 9, 10, 11, 6, 7, 8, 910. I thank you. And actually, this made much more sense for me to be able to do it than this, because I didn't have to worry about putting that 0 in the most random place. What about short division? Right, now, we don't need you to worry about long division anymore. For some reason, this has disappeared off until you get to methods 3 and 4, and then we make it harder by putting algebra in, but let's just put that to one side. So short division, what do? Well, we say 12s into 6 don't go. Well, that sucks. 12 into 6 don't go, right? So what do? Put a 0 here, and we carry the 6. And we say 12s into 63. 12, 24, 36, 48, 60. It goes 5 times. Remainder 3. 12s into 39. 12, 24, 36. It goes 3 times. Remainder 3. Now, actually, when we get to secondary school, we don't do that remainder. What do? Yep, we put a decimal point here, and a decimal point here, and a 0. Because we remember we can put in as many zeros after a decimal point as we like. So that now goes there. 12, 24. Oh, it only goes in 2 times. How many is the remainder? 24 to 30 is 6, so 6 and a 0. And there we go, we can put the 0.5. So we now know that 639 divided by 12 is equal to 53.25, or 53 1/4. Right, short division, it's just an algorithm. We just keep doing this. Why does short division work? Who knows? Knowing the rules, though, helps us try and find bits and pieces like this question here. So as we did in the previous video, if you remember, we had to try and find missing values. Right, so with this particular question, you've got to try and work out what the missing numbers are, but I would actually do it backwards. Putting these algorithms into place is really important and can be quite tricky. So, for example, if we look at this question here, we know that these two things here have to add together. So I now know that this value here plus 0 must be 4. And there's no other way of doing this other than making that 4. Now, you might then be able to turn around and say, well, hold on a moment, this here could actually be a 4 then, because 5 plus 4 equals 9. But you have an issue, and I'm going to show you why the issue is now. What could this value be here? So we're trying to find out this value here, and we know that the 4 has come from 2 times this value here. Now, 2 times 2 could be 4. So for a start, 2 times 2 would give me that 4. But you then have to say that this 2 here multiplied this 2 here gives me this value here. Well, 2 times 2 is 4. It is not 5. So before I even know what I have to, this has to have a carry. Why? Because this is only going to be a 5. Actually, put my carry in the right place. That can only be a 5 if 2 times 2 plus that carry gives me that 5. So it could be a 1, it could be a 2. So what are we actually looking for? Well, we're now looking at a number that is going to give me 14. Can 2 multiplied by anything give me 14? Yep, 7. So I'm now going to guess that 7 is my right answer. And again, it could be something else. Could it be anything else? I don't know. 8, 16, no. In fact, it can only be 7. Knowing that that is now 7, I can actually work out the rest of my numbers. So 5 plus 1 plus something has got to give me 9. That has to be a 3, and that has to be a 5. So using these algorithm rules and making sure that, like particularly for my first line here, that I actually took into account that this number here had to be created from 2 times 2 plus something else, it helped me work out the rest of the question. What about this division, right? So the algorithm has to give me the division. We could start by working through this way, but actually it might make more sense to work backwards because I've got a remainder 6. Now, what does that mean? It means that whatever my carry is here, and there will be a carry, 7 goes into this number 4 times, remainder 6. Well, actually, by doing this backwards, if I do 4 times 7 plus 6, that's going to give me that carry. Oh, so 7, 14, 21, that's 28 plus 6. And 28 plus 6, when I went to school, was 34. So that is now a 3. How does that help me? Well, remember, this carry is our remainder from doing 7 times 9 plus that remainder. So 7 times 9 plus 3 gives me 9, 18, 20. So that's 63 plus 3 must give me 66. And there we go. That has to be a 6. And if you do it the other way, then it works out. Now, this is just phenomenal that you have to then, just practice, practice, and practice. Believe it or not, that's the work that you are going to be expected to look at on top of many other things in the whole number multiplication and division. Using these shortcuts, using these mental methods, understanding how algorithms work to then help you find these sort of missing number problems. It's all practice. It doesn't come naturally. You shouldn't necessarily be able to look at this and go, oh, okay, I get that straight away. I'm 147 and can only do this now. Anyway, thank you very much for listening. I look forward to seeing you in the next lesson. Joining us for that video. It was really good having you. Now, if you'd like to know when the next video is coming, why not click on subscribe? Alternatively, head on over to MaffsGuru.com where you can watch all of the videos on its own dedicated website. While otherwise, watch the video that's just popped up. It'll be part of this series. All right, take care. See you again soon.